We've done the product rule where we've got two functions multiplied together, and we had a special rule for that. Well, it's the same when we've got two functions divided by each other. So if we've got y equals a function of x divided by another function of x, so u of x divided by v of x, the quotient rule says that dy dx, and just like the product rule where you just don't find the derivative of the numerator and the denominator and just put your answer down, it's a little bit more involved with that, and it works a bit like this. The whatever function's on the bottom, in this case v of x, in the answer goes v of x, and then we square that. So that goes on the bottom. Whatever goes on the bottom we start with, so that's v of x, and then it's du dx. So v of x du dx, always minus. Now we start here with v of x, so now we've got u of x, we do the other one, and we've got du dx there, so we do the other one, and that's dv dx. So that's a way of remembering it. Whatever's on the bottom goes on the bottom squared, and then you always start with that up there, v of x times du dx, and it's a minus. A bit more involved than the product rule. Now that's a mouthful to digest and to try and remember. So once again, if we've got u over v, then y dash is equal to all over v squared, and then you go v u dash minus u v dash. That's the quotient rule, and I would think that for the majority of you, that is the one that you will use and commit to memory. So that's a shorthand way of writing what the quotient rule is. So let's have a look at an example. So we got y equals x squared minus 4 over x cubed. Now, there's actually three ways to do this, but it's pretty obvious that we've got a function divided by another function, and that's the key thing to look for. Certainly, as it stands, is not a product, and as I said before, you can't just find the derivative of that and the derivative of that and write your answer down. So we identify our function, so that is u over v. Good communication to actually say what you're making u, what you're making v. So we've got u equals x squared minus 4, so u dash, the derivative of 2x is, of x squared is 2x, derivative of constant is 0, and we've got v is equal to x cubed, so v dash is equal to 3x squared. We then quote the quotient rule, so we got y dash is equal to, now if it's u over v, we put v squared, we start with a v, u dash minus u v dash equals, it's now a matter of just going through and picking up what is what. V squared, v is x cubed, and we've got to square that. V is x cubed, u dash is 2x, then comes our minus. Now we've got to pick up u, go up here, u is x squared minus 4, and v dash is 3x squared. Remove our brackets, and we get 2x to the 4 minus. Tricky here, because we've got a minus with a minus inside the bracket. So when we multiply 3x squared times x squared, we get 3x to the 4th. That minus, a minus will make that into a plus. 3x squared times 4 is 12x squared. All over x to the power of 3, all to the power of 2. Power to a power, you multiply 2 3s are 6, so x to the power of 6. Collect like terms. Here are our like terms. We've got x to the 4th. You can only combine them when they've got the same powers, so fourths and fourths, we can combine that as well with those. So we got plus 2 minus 3 of them, which will give a net result of minus 1. So minus x to the 4 plus 12x squared all over x to the power of 6. So there's an answer. And that's where you would stop. Or we could convert this into a product. So if you've got y equals x squared minus 4, just go back to the original question, over x to the 3, we can make that into a product. It's simply this. Now we'll bring that upstairs, and when we bring it upstairs we change the sign of the power. So if it's x to the positive 3 downstairs, when it comes upstairs it'll be x to the minus 3. So then we could use the product rule. So we could say that's equal to u and that's equal to v, and we can go y dash equals u v dash plus u dash v. Okay, and go through, and you should get the same answer there. So you could use the product rule instead of using the quotient rule, but you have to manipulate the fraction first. Or a third way is to say, right, y equals, we could split this into 2. Knowledge of fractions means that this can be expressed as x squared over x cubed minus 4 over x cubed. If you like, this is like a backward step for adding or subtracting fractions. You've got to get the denominators the same, and then you combine the two numerators together. In this case you subtract the 2. So if you like, I've got the denominators the same here, and then you make it into a single fraction. So then x squared over x cubed is 1 on x, and this is minus 4 over x cubed. We can then say that's x to the minus 1 minus 4x to the minus 3, and then we can say that y dash is equal to, now the derivative of that is negative x to the minus 2, and then the minus 3 times negative 4 will be plus 12x to the minus 4, and that will be equal to minus 1 over x squared plus 12 over x to the 4th. Now you'd need to have some solid algebraic fraction work here, and you'll find if you combine those two together you'll get the answer that we've got up there. So quotient rule, which is what it was all about, just showing you that you can usually convert a quotient into a product and use the product rule, or if you can simplify it first, it certainly makes it, well, it may not make it easier for you if you're not really good with algebraic fractions, but anyway, in this case there's another way as well.